We're going to go over what we did in class for practice 4, calculating force of gravity. First, we'd like to do is read the problem and look for anything that has a number, right? So an African elephant can reach heights of 13 feet and possess a mass of 6,000 kilograms. Determine the weight of an African elephant in newtons. So let's write down all the things that we just saw. Okay, so we have height is 13 feet, and we have a mass of 6,000 kilograms, and the question wants to know, determine the weight. Okay, so weight, remember, is Fg. All right, so anytime you see the word weight, think of it as the force of gravity between the earth and that object. So the equation that we found in class or during our lab was Fg is equal to mass times our gravitational field strength. We're going to be using the gravitational field strength of Earth because that's where we are. All right, so Fg is equal to mass. Since there's no height needed in our equation, we actually don't need it. This was extra information. All right, so we have 6,000 kilograms times 10 newtons per kilogram, and we get that this is 60,000 newtons. And that is our answer for this part. Now, to fill out the proportional reasoning portion, we are going to look at some stuff. So, let me see. When we get to proportional reasoning, what we'd like to do is first list all the A information or old information. Okay, and we're going to do just that. So here's our box that has the information, and it wants us to fill in the stuff for original, right? So G is going to be 10 newtons per kilogram. Our Fg, which we just calculated, is 60,000 newtons. And our mass, which was given, was 6,000 kilograms. Okay, so this, all the stuff that was up here. So A or original. And we're going to calculate for what it is when it becomes new. Let's change the color. Okay, so to get the new numbers, let's read what it says in the description. All right, so what would the weight of the elephant be if his mass was only 3,000 kilograms? So his mass now is 3,000 kilograms. And we're trying to figure out the weight, so we don't know what this is just yet. And since the elephant didn't go anywhere, it stayed on Earth, the gravitational field strength will stay the same. Right? So this is times 1 is equal to, actually let me write that in a different color. Okay, so times 1 is equal to, times, we don't know yet, so 6,000 times something is going to be 3,000. Now I know that 6,000 divided by 2, okay, so I know that 6,000 divided by 2 is going to give me 3,000, but the problem here is we want something to multiply. So if we have divide by 2, when we're multiplying it, we could just multiply by the reciprocal to get the same answer. So we're going to multiply by 1/2. So this means that these are our coefficients, and these are the variables, and we're going to fill out the proportional reasoning section now. Okay, so it says that our gravitational field strength stayed the same, and our mass went down by 1/2. And so now we know that something over itself is going to equal 1, And so that this must be 1/2. So 1/2 divided by 1/2 is 1. And that's just a property of 1, that anything divided by itself is going to be 1. Okay, so the coefficient, since this was the last one we filled out, is going to go here. Our variable is FG because that's the missing variable. That was our question mark. And now our 1/2, and the original value of the question mark, or the FG, was 60,000 newtons. So we're going to fill that in, and we have 1/2 of 60,000 is 30,000 newtons. And that's it.